All right, gang. So I hope you enjoyed that video, and it kind of gives a preview to what we're going to be talking about when it comes to memory and memory systems. And one of the techniques, again, he kind of alluded to it in the video, is the idea of building memory palaces. All right, gang. So I hope you enjoyed that video, and it kind of gives a preview to what we're going to be talking about. That was weird. When it comes to, there we go. Um, And there is a few things. Well, I can't even think about it now. There were a few things that I just want to mention about that video as we move forward, and that's about the things about deep processing and doing associational hooks. One study tip that we can immediately start off with is if you can connect new information to already known information, it will be remembered much easier. And that's why I would encourage you, when you're studying psychology or any of the social behavioral sciences or whatnot, anytime we talk about a process, a human process, try to connect it to something you know and you can visualize, and that will help understanding the information as we go. But that's also why things like mathematics and stuff are a building process. So we learn addition, subtraction, then we build on that with multiplication, division, and it's a building process because we want to have that association with previously known information. Sometimes it works, sometimes it doesn't. But I want to talk now about memory and kind of what just some basic definitions and concepts with memory systems and memory and how it works. And the first place that we really should start is, where did the study of real memory come from a scientific perspective? Of course, we've been studying, as he mentioned, memory. We have treaties dating back 2,500 years ago, those types of things. But where did our modern understanding of memory and memory systems come from? And it started to develop during the rise of the computer age. In fact, many even computer information systems people feel like what humans did when they created the computer was they basically subconsciously mimicked the human memory system, okay? And so just like a computer, we have three basic processes. We have an encoding process, which is getting the information into the system. So this is the keyboard, this is the microphone, this is the video, which is taking information. And if you think about it in the sensations section that we already did, it's getting information in and it's making sense of it. So when we type on our keyboard, it will give us some sentences and everything else. And that's kind of the basic process of encoding, is getting information into the system, okay? And then the system needs some way to store it. And so you could think of this as your kind of, when we look at this, we're going to look at short-term or working memory, which is like RAM in a computer, or the random access memory, that it works with, programs that are open that you're working with. It's the information that is being put in and organized in the system. And then it goes to the long-term system, which is kind of like your hard drive or the cloud, where that information is then stored. Then when we need it again, we can easily retrieve it and get it back. And that's a retrieval process. And then again, memories are always a building process. Once we retrieve it, we may continue the encoding processes by changing it, improving upon it, and the like. So let me go back. Well, we'll get to some of the nuances about each of these here in just a few minutes, but I want to talk about the encoding process first, okay? Encoding is basically our sensory input, so it's a keyboard putting it into the word processing machine and making sense of it. And there are two types of encoding. One is automatic, and one is effortful, okay? Automatic encoding usually occurs when something is very highly emotionally salient. Okay, so for example, you don't have to watch videos of, if you were alive then, of 9/11 over and over and over to remember that 9/11 happened. That's an example of automatic encoding, because it probably was a highly emotional situation, and that information is stored for later use in some way. Effortful encoding is more what we're doing in the classrooms. This is where we take the time to write some notes, work with the instructor, maybe do some activities to purposely develop and understand new information or manipulate different types of information, okay? So those are the two types of encoding. Again, the automatic works mostly on the emotional level. And we know that emotional memories are stronger than what we call semantic, or what we do here in the classroom memories. I would be willing to bet at the end of the semester, you'll remember something either sad that happened to you, or something that was really cool and joyous that happened to you, more than you'll remember this lecture or any of the lectures that have been provided in the series so far, which makes the college years interesting in that aspect. Now, when we are trying to encode, this brings up the issue of attention. Okay, and we have basically three types of attention. Okay, selective attention is paying attention to one stimuli in a purposeful way. So, selective attention is if you're really paying attention to this lecture and ignoring maybe a roommate or a radio or a phone or something going off in the room. That's a form of selective attention. You're focusing only on the stimuli, and you're censoring anything else out at the moment. Okay. Divided attention is multitasking. And this is when we select to do more than one, pay attention to more than one stimuli at a time, okay? And there's been a lot of arguments. Are humans good at selective attention or divided attention and multitasking, or are they bad at it? The truth is that we actually are not that great at it. Even people who, when we test people who say they are the best multitasker in the world, we test them and they make just as many errors as the person who says they're the worst multitasker in the world. And so when it comes to, are there people, are we really good at it? The truth is that we're really not. But there is some caveats to this, is that can multitasking be trained to some degree? The answer is we think so. And that comes to the study of gender differences. Because when we look at gender, male, female, we do find that females tend to be slightly better, or at least statistically significantly better than males at multitasking. But there's a caveat to this. Females are only better multitaskers after they have given birth to a child. Okay. Now, what do I mean by that? A lot of these studies deal with going back to the workplace after giving birth to a child and going through the maternal areas and raising the child for the while, and then the female returns to the workplace. And we find that when they return to the workplace and when we measure it, they tend to have more accuracy on multitasking tasks. They tend to do tasks a lot more efficient. Okay. Now, as I said, I mentioned before, what does this have to do with training this to some degree? Well, what we think is going on, or at least the most current theory suggests, is that when a mother especially has an infant, that infant for the first 24 months is totally and completely need of a mother's attention, except for maybe when it's sleeping. But even at that point, the mom is constantly checking in to see if the infant is awake or not. Okay. And so there's this infant that needs all this needs continued attention. But then there's all the other tasks of life, like, well, if you're at home, cooking, cleaning, paying bills, taking care of other things, making sure the infant has all of the, the diapers and all those things. And so at the same time, the mother has continued attention to the infant, it also requires her to make a cognitive adjustment because she also has to attend to all of the other items of living. And over time, we think that this is a training thing, that the mother tends to become better at these things we call multitasking. Okay, so that's multitasking, and again, this is of some debate because there's also some potential biological aspects to this argument as well, as we know that moms tend to produce more dopamine and acetylcholine, which open up the learning centers and attention centers of the neural system. So there's probably some biological aspects of why this occurs too. But really with multitasking, we only see this gender difference with individuals who have children. I will tell you, I haven't read research on yet. I'm hoping to see some to kind of look at this debate about single fathers or fathers who are the primary caregiver for their infant, to see if they have that same type of ability when they return to the workforce, or if it increases their multitasking ability. I haven't seen that research done. I think it would be very interesting to see. So we'll have to kind of put a pause on that. Right now we have a gender difference because we haven't measured our fathers who are the primary caregivers. So there's also what we have sustained attention. Okay, this is when we're intently vigilant on a given stimuli. So again, just kind of like selective attention, you can have sustained attention on this lecture where you feel like you're having the sustained moment, you're listening to a lecture. But here's the issue with sustained attention and what we think is vigilance, is our brain does a trick on us, is it makes us feel like we have sustained attention when we really don't. Okay, and let me explain this a little bit. So I know that hopefully you feel like you listened to this entire lecture to its entirety, to the end, because you find it amazingly interesting, right? And so when you get done, you feel like you spent the last 60 or so minutes with sustained attention to this sustained attention to this lecture and whatnot. But what I know on a neural end is, in the end, you'll only remember about 10, 15, maybe 20 minutes of the entire lecture in a long-term version. And the reason being is our neural network, okay? Because what needs to happen is at about every 15 to 20 seconds, the nerves that are having attention burn out. They need to recharge. And so every 15 to 20 seconds, either consciously or subconsciously, our attention is averted to something else. We may not realize it or not, but it occurs because those cells in the brain that is paying attention to this lecture need a little bit of a break. And then about 10 seconds later, the attention, those nerves who are paying attention to this lecture, kind of putting it in a strange way, will come back and avert to this lecture. If anybody has ever heard a really awesome lecture that you've just really liked, or a speech or a TED talk or whatever it may be. And you're like, gosh, I need to tell everybody about this. But then you go home and you tell your friends or your family and you try to repeat that lecture or that speech, and you kind of get disappointed because it didn't turn out the way that you remember it happening. It just, the words didn't come out and you can't explain it kind of the way you feel you heard it. This is that process, is that the brain kind of tricked you in thinking that you sustained attention and you understand it completely, but it's not remembering components when you're trying to recall it at a later date and trying to explain a concept to maybe your parents or your roommate or whoever. So that's the issue we have with sustained attention. Okay. All right, and within encoding, we know that we have three types of processing, and these kind of happen in conjunction with each other. Okay, and I think this next slide is the best one to kind of explain these different levels of encoding. Is we start with shallow processing, which when we're doing shallow processing, we're just getting the physical and perceptual features. So we're lines, angles, those types of things. And then on the next level of processing, we have intermediate, which is we recognize the stimulus and we give it a label. So here we have shapes and such as a car are detected, and then we give that object a label and recognize it as a car. Okay. And then on the deep processing level, when we're really into it, is we give that car even more meaning. Maybe it's our favorite kind of car. We recognize it as a Porsche or a Ferrari, and we think of having fun, driving, those types of things. So it becomes a memorable object. Okay. Why is it important to understand these levels of processing? Well, I think it's important because later on, probably next week, we'll talk about something called eyewitness testimony. And eyewitness testimony is something that the courts accept blindly in our court system. But we have found in research and in science that it's highly, highly, highly unreliable. Because the majority of time when we're walking around and we're exploring the world, we're focusing on some primary objects, the things we want to focus on. And when something happens, we're not necessarily processing it on a deep level. We're processing it on a shallow level or an intermediate level. These two types of processing often do not make it to long-term memory. And here's my challenge if you doubt me. How many trees did you pass by while you were walking to a class today? Was the grass green, or was it getting brown, or was it a mixture of both? What was the ethnicity of all the students you passed by when you were walking to a class? What was their age and their hair color? And I would be willing to bet there probably might be one or two people in the class that would go, well, I have this kind of memory, and it's kind of what we call photogenic, and I remember all of that and I can describe it. But then I challenge you and go back, let's go test the accuracy of that. And often we will find that we really are not paying complete attention to our world. Our brain is filling things in for us because our brain is usually processing at this level, because I'm willing to bet on the way to class, you are focusing on your steps and what you need to do to get to that class, what you're going to expect when you get to that class, what the meaning of that class is going to be. And this is what you're focusing on. So when we put people in a lineup, when we ask people to witness what they saw at a testimony, oftentimes it's very, very inaccurate, especially when it comes to bystander type of testimonies. Okay. Now, when it comes to direct victimization, and I want to make this clear, dependent on the victimization and the trauma that occurred, it can be accurate, but it also can be inaccurate. And we'll get to that when we get to emotions and memory, and how sometimes our traumatic memories are very fully functional, and at other times it creates a complete almost delusion of what really happened. But we will get to that probably late on next Tuesday or early next Thursday. Okay. So how can you increase encoding to assure that information gets to your long-term memory? We call it elaboration, as he kind of mentioned. We really get and play with the information, and we connect it to our memory systems. When we do this memory palace, what I'm going to have you do is create a room in your mind. It could be a dorm room, it could be your room at home, it could be a totally new one. And what you're going to do is you're going to set 7 objects in there, maybe a couch, a TV, a PS5, a plant. And with each one of the things that I'm going to ask you to remember, you're going to have that thing do really crazy things with that object. So for example, if I ask you to remember a gallon of milk, maybe you see the lamp in your house and there's milk spewing out of the little ends and the little fringes of the lamp, and there's a cat licking up the milk. And that's what you're going to do. That's the elaboration process to remember. Basically, what I'm going to give you this Thursday is a grocery list. And that's how you'll remember. You'll walk through that room and you'll see that lamp and you'll remember, oh, that's the cat, the milk. Why is it coming out? Okay, I need a gallon of milk. Okay. So that's going to be kind of how we're going to learn about elaboration and how elaboration can increase encoding and get stuff into our memory system. The other thing that we should talk about when it comes to encoding is we have really 2 types of encoding. Now, there are others, there's olfactory and whatnot. And in fact, I will tell you, our best memory system is smell. And if something is smelling according to a previous, that's why, a lot of people associate certain types of cooking with grandma's kitchen, okay, and those types of things. But the 2 that we've paid most attention to in the research are verbal encoding and image encoding. And the question is which is best, which is better? And this is where I want to bring up the notion of learning styles. And I think we talked a little bit about this in the beginning of the semester when we were talking about myths and whatnot. Is there's this assumption that there's a multi-million-dollar industry about learning styles. So learning styles, do you learn better visually by looking at objects, verbally by hearing things, kinesthetic by interacting with the object, and those kinds of things. And in the industry, what you're supposed to do is you're supposed to match what you're learning with your learning style. So for teachers, when you gotta tailor to each of your students' learning style, or for the student, they say, when you're learning something, hear it auditorily, you should do that, and that will increase learning. And what we have learned from that is that it's total waste of time to do that. Okay. Now let me explain why. Over about the last 15 years, there's been several what we call meta-analyses. Okay. What a meta-analysis is it takes a whole bunch of studies that studied the same thing, and it statistically squishes them together to see if the effects found in that study stick or they don't. Okay. And what we have found by doing several meta-analysis on learning styles is that it's really a bunch of crock. okay? In that you're actually at a disadvantage by trying to learn something at what you consider your preferred learning style, okay? Indeed, what we have found is if you really, really want to remember something and you really, really want your memory to be efficient, let's say you think you're an auditory learner. So the opposite of auditory learning is visual learning. What you should do is visually learn that. You should go read it. You should go see images of it. You should force yourself to do it in a visual format instead of auditorily. Why? Because that makes you deep process that information and understand it at a deeper level than if you just do it at a shallow process level by doing it how you prefer to have it done for you, okay? So one, again, coming back to study skills and higher education, another lesson is make sure you're not always using your preferred learning method, the thing that's easier for you, you think is easier for you. Use what's more difficult. The second thing that we have learned with learning styles is really to enhance it even further, you should do it in multiple learning styles. So you should hear it, you should read it, and then if you have the ability, go interact with it in some tactile way, okay? All right, so there's lesson 2. What was I about to say? All right. When we get in another example of why the idea of deep processing is when we get to the section on intelligence, which we'll get to next week as well. And we think that, people of lower intelligence are stuck at lower intelligence and the like. And there's some really interesting studies done on, there's a type of intelligent test that is an analogy test where you have to read something and then you have to solve some type of analogy or some type of a code of some type, okay? And in the way these are scored, they're equivalent to doing a full-blown intelligence test. They score very similar. They have what we call external validity, okay? And there's been some interesting studies where they've taken individuals who score on the normal intelligence test that scored from now intelligence, the average is 100 and it deviates by 15, okay? And we've taken individuals that score on a standardized intelligence test that scored between 85 to 100, so below IQ level. And what they did is they randomly assigned the individuals into 2 groups. One group read the analogies and whatnot in just the regular font that the test comes in. The other group read it in a very difficult font, a very hard to read font. And then, of course, they scored the analogy test afterwards. And there was an interesting difference between the groups. Is the group who read it in the normal font scored exactly what they scored on that standardized test, between 85 to 100. What was interesting was the individuals who read the difficult font analogies. Their score actually increased. Their scores went from 85 to 100 to 100 to 115. So at average and above. And the idea goes back to this idea, I'm going to poke back here, oops, about this elaborate and deep processing of information, that when we take the time to really focus on something and to do it in almost an uncomfortable way and in an effortful way, we'll be more likely to retain that information in the future. Okay. So I kind of want to end class today with talking about one of our first memory storage theories. because one of our tasks this coming Thursday will be to actually measure your short-term memory. And so I kind of want to go over this memory system. Now, again, it works just like it's a computer model. Here we have the keyboard. Here we have the RAM, or the random access memory. So it's your little 8 gigabytes that you're able to open and close different programs with and run programs on while it's actively there. And then we have your hard drive, the long-term memory, okay? So let's go through each one of these, and this is kind of the model. Here we have sensory memory, which is a very rich, detailed, very brief, half a second type of system. And then when we pay attention to aspects of our sensory memory, it goes into our short-term memory where we're able to work with it. In the original model, it was assumed that through rehearsal, this is how you work with things and eventually get it into long-term memory. We'll see that this model really isn't the best when it comes to how you get information from this memory system to the long-term memory system. And then, of course, we have retrieval, when we need to make sense of things that we're attending to based on previously learned information, okay? So this is, if you want to think about this process, this is reading a question on an exam and recalling what the appropriate answer would be. So this is that process there, okay? As I mentioned, we have the sensory memory, which is a rich, detailed information held in originally sensory form. And it's very, very brief. We're talking a half a second or less. And we've tested two types, echoic or iconic type of memory, basically auditory and visual, and using different test methods of presenting information for half of a second, like a picture for a half a second, and then having somebody do some type of recall thing. This is how we measure this, and we know that it's a very rich, detailed system. And then out of that, we decipher what we're going to attend to, which then goes to the short-term memory, okay? And this is the memory system that we're going to test this coming Thursday, because like a hard or RAM memory, maybe you have 8 gigabyte RAMs or whatnot. Human beings have a short-term memory capacity too, or a random access memory as well, and it's 7 plus or minus 2 chunks of information. Okay, so for any individual, on average, we can hold 5 to 9 bits of information at a time, okay? And now what does this mean? So for example, we're gonna test your short-term memory this coming Thursday. Again, remember to bring a paper and pencil or pen to do this. What does it mean? Let's say we have a limited capacity. Let's say, because this is actually mine, I'm actually a little bit below average. My memory, short-term memory capacity is 4. So when I'm studying something, I always chunk things in 4s, okay, that can be processed within 30 seconds. So let me give an example of this really quick and what you can do with it after this Thursday when you know your number. So when I'm reading a chapter in a book and I need to study it for some type of exam or a lecture or something like that, what I do is I read the first 4 paragraphs, and then I make sure that I spend time to study these first 4 paragraphs and understand what's going on in them before I go on to the 5th paragraph, okay? Because this is what's going to happen. So I read these first 4 paragraphs and I'm holding them in memory, okay? But then when I read this 5th paragraph, this first paragraph is going to jump out of my short-term memory, and it's not going to be accessed into and transitioned into my long-term memory, okay? And then when I read the 6th paragraph, the second paragraph is going to jump out of short-term memory. And if I haven't really made any associative hooks with it or anything like that, I'm more likely not going to remember what was in that paragraph as well. Okay. So this is a way that you could use this information that we're going to go over Thursday to improve your studying skills, so that you can make sure that information that is being held and worked with in your short-term memory gets transferred to your long-term memory. So we'll do this activity this coming Thursday. Okay. And this is just kind of some of the stuff that I was talking about, and we'll stop here right now, because I want to get into a more elaborate, I want to have a conversation about this next topic, which is working memory, which is an elaboration of the short-term memory. And we'll talk about long-term memory on Thursday once we go through the memory palace, and we'll talk about all these different long-term memory systems and retrieval. Is ways you can improve your short-term memory. As I mentioned in my example before, I can hold 4 items in my short-term memories. So I chunk, when I'm reading paragraphs, I chunk paragraphs into units of information. So the first paragraph is one chunk, second paragraph is the second chunk, and so on. And there is information on short-term memory that rehearsal, conscious repetition of information, can prolong holding information in the short-term memory. But this is a warning about her rehearsal. Rehearsal will hold information in your short-term memory, but unless you elaborate on it, unless you process it deeply, it's less likely to go into long-term memory. So this, I remember when I was a kid, they used to give us lists of words to memorize, to for spelling bees, and the method back then is you rehearse the word over and over and over and over and over. And most of the time we kind of sucked at spelling bees and those kinds of things when we only utilized the rehearsal method of spelling. So it's a very important point. Rehearsal will only keep things in short-term memory, but you have to do something with it and deprocess it to really get it into the long-term memory system. Okay. So with that being said, I just want to